Hi friends, welcome to my YouTube channel TKF Electronics. Actually, I have seen one video, it looks good to me. So I just want to share this video to my YouTube viewers. Please have a look on it.
Hi, my name is Lotte Willems. I'm a business development manager at Holst Centre. And I'm going to show you a few things that we have developed today. So we are a research institute, and I'm going to show you some different examples. So first of all, we have laminated flexible electronics into glass. So this is just a near field chip, but it's quite interesting that we were able to integrate such thick elements into glass.
How do you put it into the glass?
So it's laminated, as you can see from the side. So we print it on a flexible PVB material, and then we laminate it.
All right. And what is this one?
So this one, I like it a lot. This is a transparent capacitive touch with integrated LED, also in glass.
So is this unique, very special?
Yeah, this is pretty special. This is the first year that we show this at IDTechEx. So this is for us,
So it looks cool, but it could be like industrial designers probably love your company, right? They love Holst Centre to see what's potentially possible to design in the future.
Yes, definitely.
Because if you design something that looks like that, you could have a killer kind of product.
Yeah, so for example, people came to us today and they talk about using this in buses, so that in the glass of the bus you can integrate the signaling that you, like the bus number and things like that.
All right. And what is this?
So this is a flexible LED display, and the circuit for it is all screen printed, and it's flexible, so we can move it in any direction. And we are actually also looking at using smaller LEDs, and we are also discussing for the future to move to micro LEDs. So a lot more brightness.
Pick and place of the LEDs?
This is still pick and place, but we're looking for the future to do mass transfer with laser-induced forward transfer.
So all this stuff that you show here is like cutting edge, right?
Yeah, definitely.
Holst Centre is all about doing cutting edge future stuff, right?
Yeah, that's true. Yeah, we are really developing a lot of new technologies and look together with partners how we can implement those.
What is this?
What you see here, the large blue field, is actually a very large pressure sensor. And you can see here the signal. And these are all different sensing nodes, as you can see.
Yeah.
And it's pretty nice because it's completely printed. So this is already pretty big, but you can make it even bigger.
So that's huge.
Yeah, it's really nice. So you can either use it in a bed to detect how a person is laying, or you can also use it, for example, in a car seat to detect also the posture.
To detect how big the person is, or not really?
No, it's a pressure gradient, so you can see the motion, but we can also make it in a higher resolution, so having many more measurement points close to each other.
In theory, it could be for like weight measurement. Yeah. How about, what is this?
This is actually a headband that we made together with Nerex. It's now commercially available. So this is one of the products that we worked on together. It's a prototype. And as you can see here, there is all these diodes, and they actually generate infrared light. And if you wear this, you can use different programs, and the infrared light will go into your forehead, and then you'll be more relaxed. So it's to reduce stress.
Infrared in your head in this commercial.
And it's commercial. You can buy it.
So is it scientifically proven that it works?
Yeah, actually it's from a startup from MIT originally. So they found out that infrared light is actually reducing stress, and that's afterwards they came to us to work together on this prototype, which is now commercially available.
It's not like frying your brain and then you become calm. That's not what's happening.
No.
I hope not. All right.
Yeah.
Cool. What's happening here?
So we also have a 3D printer. So this is all 3D printed electronics. And so the nice thing is that this is all done within one system. So we start with creating the cavities, then we place these components, create the grooves here, and then we dispense the tracks into it, and then we can close it up. So you start with a digital design, and you end up with a fully integrated chip, which is also even watertight. So you can throw this in the water and it will still function. So the benefit of this is that in 3D you can really miniaturize your electronics. So people are looking into that, for example, for electronics in earpods, because they have to be very, very small. So that's why they are looking into using 3D printed electronics.
Those TWS Bluetooth earphone
yes,
things.
for example, those very small earpods.
How much of a Holst Centre is awesome future kind of prototypes, and how much becomes very big mass market?
Ooh. I would say that most of it is very fancy future prototypes.
And then the partners can bring it to market more or less fast. How do you get all this cool stuff sooner into the mass market?
So that's by collaborating with us and collaborating because we have many partners throughout the value chain. So we are in contact with the mass manufacturers as well as the material suppliers as well as the end users. So by working with us, we are able to bring all these partners together and to bring those products to market.
This one I saw it at another booth, right? What is this?
Yeah, so this is actually a health patch. So this is a health patch with a 5 electrodes. So this can measure ECG and it also can measure SpO2. And you can wear it for 5 to 10 days on your body. So it's powered. And it's wireless transmitting the signal, so it's using Bluetooth. And you can do sports with it, you can shower with it, and you can use it, for example, to monitor your vital signs at home after you come home from, for example, a procedure in a hospital.
Is that mass produced? Is it the market or not yet? Also,
this is not yet on the market, but Philips is looking into it. So we work
Philips
together.
is not far from the Holst Centre, maybe.
He is they are a partner of the Holst Centre. Yeah,
right.
Also.
And just behind on the screen, I was seeing something about it looked like free self-driving cars, or do you have stuff going on with that?
Yeah. So actually, the pressure mat that you see here, if we can, this is pressure that I showed, but we also have piezo material. And
so what does that do?
What it does,
vibration?
It generates a voltage as I move it, and you see that it's very soft and flexible. And if you put this in a chair and you sit on it, it can actually measure your heartbeat and your heartbeat variability. So what we want to do, what you see here, it's very small, but we want to make this at the same scale as this. And if you do that, we want to have that every measurement point not only measures pressure, as we showed today, but also measures piezo, and we can even implement as well a temperature sensor there.
So what's the process for you to get something small like this to big?
So actually it took us quite a bit to make it small like this, because this is made on a TPU and it's very flexible, so we had to do a lot of process development to make it so soft. And now we know how to do this. We can scale it up and do it bigger because we have the facilities in house to do that.
So how's it been for you, the IDTechEx show?
Oh,
how was it?
Actually, it's my first IDTechEx show, and I think it's a great success. We met so many interesting parties.
And lots of people looking at all your cool demos, right?
Yes, lots of people looking, and it's very nice to hear what they're looking for and how we can together make sure that printed electronics make the way to market faster.
What is this?
What you see here is a temperature sensor array. So what we do is we take the traditional material that is used for NTCs and we make it into a composite, and with the composite we print, and as you can see we can make a very large temperature array.
Nice. And that one, is it similar to the other pick and place LED machine you showed before?
No, so this is what we call in-mold electronics. So this is made starting with a single substrate which is flat, and then we add the graphical layer, we add all the electrical layers, and afterwards we thermoform it to shape it. So we heat it up to shape it into this 3D form. And then here now on the sides you have a human machine interface. So these are capacitive sliders, and here there's a capacitive touch function.
All right. That's cool. What's happening with that one?
This is 3D printed, so what the cool thing is about it that is 3D printed is that there's no wires, but we integrated like conductive lines. We printed conductive lines into the structure, and yeah, you can make it in any shapes. You have complete freedom to design it in any form.
Nice. Cool. It's always, you're always very close to being the coolest booth at the show, right? Don't you
Nice,
think?
that's good to
Have
hear.
you been around? Have you been around?
Yes, I've been around.
Because
yeah.
this is all like attention-grabbing stuff, right? It's like
Yeah, that's the idea.
special,
Yeah,
and it looks cool.
yeah, it should inspire
this
people.
one right here.
Yeah, it's
Lightus.
beautiful, huh?
What's
Yeah.
the status on that one?
So we have a proto line. We have a proto line where you can, basically
Yeah.
order flexible OLED products.
Flexible OLED
Yes.
manufacturing
Yes.
for
Flexible OLED manufacturing.
more than prototyping, just prototyping.
It's really a prototype line, so it's not a mass manufacturing line.
All right. But you have all the expertise, huh? How to turn prototyping into mass manufacturing. It's one of the big challenges.
Yeah, that's correct. Yeah.